After the limitations or failures of Newland's law of octaves, many chemists searched for a new trend for the classification of elements. Just in this search of a new trend, a Russian chemist named Mendeleev came up with his new idea of periodic law. Now, what this law is, what are its achievements and limitations? To know your answers, watch this video complete. Hey viewers, this is Devinder Kaur and you are welcome to my YouTube channel, The Enlightened Room. When Mendeleev proposed his periodic law, only 63 elements were known in that time. So what he did, he classified those elements, number one, on the basis of the relationship between the atomic masses, and number two, on the basis of their physical and chemical properties. In physical properties, you can take boiling point, melting point, etc. And in the chemical properties, you can take their reactivity with the hydrogen and oxygen. Now, why he opted out for the hydrogen and oxygen? Because hydrogen and oxygen are very reactive in atmosphere, and with all of the metals or non-metals, you can say most of the elements, hydrogen and oxygen are found reactive. That's why he opted out for the hydrogen and oxygen. So what he did, he took 63 cards and on each card he wrote down the properties of one element. He sorted out the elements with similar properties and then pinned the cards together on a wall. So what he observed from this? He observed that most of the elements got a place in a periodic table and these were arranged in a order of their increasing atomic masses. It was also observed that there occurs a periodic recurrence of elements with similar physical and chemical properties. So on this basis, Mendeleev formulated a periodic law which states that the properties of elements are the periodic functions of their atomic masses. Now let's take a look, how does a Mendeleev's periodic table look like? Now you can see the Mendeleev's periodic table. As you can see, this table contains vertical columns called groups and the horizontal rows called periods, just like the modern periodic table. Now let's talk about the achievements of Mendeleev's periodic table. The first achievement you can see is that the elements with slightly greater atomic mass were placed before an element with a slightly lower atomic mass with an inverted sequence so as to group the elements with similar properties. Now you can take an example of cobalt with an atomic mass of 58.93, which is placed before nickel with atomic mass 58.71, so that their properties are similar to the elements below it. Now you can see the properties of copper are similar to rhodium and iridium, and the properties of nickel are similar to platinum and palladium. Another example is tellurium is placed before iodine. The atomic mass of tellurium is 127.60 and that of iodine is 126.90. Another achievement of Mendeleev's periodic table is about inert gases or noble gases. These gases were discovered very late because of their unreactive nature and low concentration in the atmosphere. You can take the example of helium, neon, argon. But when these gases were discovered, these could be placed in a separate group in Mendeleev's periodic table without disturbing the existing order. Now another achievement and the biggest achievement of Mendeleev's periodic table is that he left some gaps in his periodic table. Now instead of looking upon these gaps as defects, what he did, he boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral Eka, which means 1 to the name of preceding element in the same group. You can take the example of Eka boron, Eka aluminium, Eka and Eka silicon. Now the properties of Eka aluminium predicted by Mendeleev and those of element gallium, which was discovered later and replaced Eka aluminium, as you can see from this table. The atomic mass of Eka aluminium and Eka gallium is quite very close to each other, and the formula of oxide and formula of chloride is also correct. Now similarly, the Aka boron was found to be scandium. The properties were very similar to each other, and the properties of Aka silicon was found to be germanium. This provided the convincing evidence for both the correctness and the usefulness of Mendeleev's periodic table. Now let's talk about the limitations of Mendeleev's periodic table. The first limitation is related to hydrogen. As you can see from this periodic table, the position of hydrogen is in first group. Now the electronic configuration of hydrogen resembles with the electronic configuration of alkali metals, like it combines with oxygen, sulfur and halogens to form compounds having similar formulae. But just like halogens in group 7, hydrogen also exists as a diatomic molecule, and it does combine with metals and non-metals to form covalent compounds. So it can be said that no fixed position could be given to the hydrogen in the Mendeleev's periodic table. The second limitation is related to isotopes. Isotopes were discovered much later after the Mendeleev's periodic table was proposed. Now what these isotopes are? Isotopes are the atoms of the same element having same atomic number but different mass number, and these isotopes could not be properly fit in the Mendeleev periodic table as there was no space for them. Now the third limitation of Mendeleev's periodic table is that the atomic mass of elements do not increase in irregular manner. Now this made difficult or not possible to predict how many elements could be discovered between the two elements. And this one is especially in the case when we consider heavier elements. To watch the complete video lessons of this chapter, subscribe to our YouTube channel, The Enlightened Room. You can also follow us on Facebook and Instagram.